This video was produced in the framework of the CLIMED-FRUIT project, and will allow you to discover one operational group involved in the project, and the different results and testimonies that resulted from it. Starting, a little tutorial to remind you how to put YouTube subtitles in your language. First, click on the Settings button. And on the Subtitles button. You can click on the auto-generated proposal. Once it is done, click again on the Subtitles button. Now choose your language. Here we are, now you are ready. Let's start with the general presentation of this operational group.
Italians' food spending has radically changed. The authenticity and quality of food and the protection of the land are becoming new reason for consumers to make conscious purchases. They have found an answer to this request in organic products, generating a stable upward trend in demand. Thanks to the support of currently available research and technology, much can still be done to increase innovation in organic products. In this very dynamic context, the operational group Oltre.bio was set up in 2020 with the desire to go beyond the traditional approach to organic farming methods as a means of experimenting with the adoption of innovative cultivation practices that are consistent with safeguarding the environment and the health of workers and consumers. Agricultural activity adapted to local conditions, adaptation to climate change, rational use of resources, production of quality food, respect for the soil and work in the fields, and the interaction between the world of research and production are the cornerstones of the operational group Oltre.bio. Therefore, at the project's core, there is the need to raise the competence of the organic sector while maintaining its own identity of production and territory. Oltre.bio took root in Apulia, one of Italy's most organically productive regions, starting from analyzing the characteristics of two sample crops, the table grape and the cherry tree. The project aimed to improve the organic management of the two species through an ecosystem approach involving the integral management of soil, water, and living resources. Table grapes and the cherry tree are significantly affected by agronomic and post-harvest techniques. The protagonists of this process were the farms to which, during a series of demonstration days and workshops, a holistic view of the plant-soil environment system was transferred in order to prevent possible biotic and abiotic adversities, improve the quality of the fresh product and increase the shelf life of the finished product. The main results of the Oltre.bio project lie in improving soil fertility management, soil cover and product shelf life. The main achievements of the research carried out in the Oltre.bio operational group. Use of compost deriving from internal company production, with cultural residues that have been valorized and used in the production cycle. Production of 2 phytosanitary management notebooks for the cultures in question, with in-depth studies on innovative phytosanitary control techniques. The development of a protocol for using the blow device in combination with modified atmosphere packaging to improve the shelf life of table grapes and cherries, the design and realization of an industrial-scale prototype to apply the blow device during packaging operations. Finally, during the whole period of the project activities, thanks to the monitoring work carried out by the agronomist technicians, the phytosanitary bulletins were drawn up at the operator's service, published weekly on the web page of the operational group. Those who embrace the new methodologies can go beyond classic organic management. They will be able to have more fertile soil with in-turro grassing, green manure and composting techniques. They will be able to manage adversities better thanks to the use of antagonists and microbiological preparations capable of combating new emerging pests and, at the same time, the use of advanced sensors for microclimatic monitoring, rational irrigation management and forecasting models of adversities. And finally, They will be able to better manage the post-harvest phase and packaging by using the blow device in synergy with cold storage and a modified atmosphere to increase the shelf life of grapes and cherries. The close cooperation between farmers, researchers, and agronomists at the different stages, from the field to the sales shelf, made the achievement of Oltre.bio results possible. Adaptation to climate change concerns all of us, so it becomes essential to review agronomic management practices, empower the organic sector through new technologies, and help farmers to be part of the solution, not the problem. We must go further towards a healthy future for our planet and us.
Now that you know more, let's see the results that came out of this project.
Started at the end of the 90s. What you see on the left part of the screen is that normally the spontaneous inherbiments or grasses among the fields and even in the cherry trees was something very common. Due to the absence or lack of irrigation is something that we have to tell about, because during the summer period it's difficult to maintain a cover grass on the soil. But let's say the first and for them quite important achievements that they had from the grass spontaneous on the field was to preserve the organic matter, which is always a problem in our fields. The absence of water stagnation, because we have even some slopes. The final target of the innovation were to improve the soil characteristics, not maintain what we have even as fertility, the increase of organic matter as far as we can in the soil, the yield increase of the orchards, and last but not least, saving the cost of fertilization. That means increase the farm costs. To do this, we started to, let's say, explore the possibility at farm level to produce their own compost. So the on-farm compost is, first of all, one of the basic concepts of the cycle of the carbon at farm level in organic farming practices. And so this is an example starting from a cherry tree, one of the cherry tree farmer. We start with animal manure because the farm has many animals, with the green residues coming from annual crops, mixing them, and after, depends on the quality of the matrices, from 60-90 days to produce their off-farm compost. This is not only a, let's say, saving money practice, but it's also something that is quite linked or, let's say, pictured in a different approach for the sustainability and the circular economy. In the linear economy, as you see on the upper part of the slide, the raw materials comes through production, distribution, retail, and then becomes a waste. In the circular economy perspective, things are completely different. The raw material should be produced, and retail should, even through the consumer reuse and adjustment, return to the soil through the recycle process. Recycling is the keyword of circular economy, and even probably something that has good and benefits for the environment and for the climatic change. Then the first question of the first quiz is about composting. Composting is a brewing technique. Tea is the tea of compost in poor words. That means that we have to make a water-based extract starting from the compost that can be in presence or absence of oxygen, so aerobic or anaerobic. The presence of other kind of microorganisms, because normally in the compost we have bacteria, but even in this kind of, let's say, evolution of the compost like tea, we can have fungal and bacteria as well. And could be something that I can enrich or adapt to my willings for subministration to the soil. Normally, the process of brewing that you see in a schematic way here, using some normal things without any kind of sophisticated extraction, can last between 5 or 8 days. And depends on which kind of fermentation we want to occur, or depends on which kind of final product we would like to obtain. At the end, we add in our farmers, especially in the cherry trees, one normal fertilizers, the compost, and especially even the tea compost. So we tried several subministration. This is in cherries, in which we mix the green compost from their own farm to compost tea, or only the green compost, or animal manure mixed between them, because the farmer was able to mix the different animal manure production, so from cows, from horses, and from poultry, and then a testimony or a test in which no fertilization was done. This was on the lapping cultivar of cherry. The second one was applied always in the same farm, but on table grapes. Of course, everything is inorganic. More or less, the pathway of fertilization were the same. And this was out of the farm, but in another farm of the Oltre.bio, always in another cultivar. We always mixing this kind of fertilization, using even the chemicals, of course, allowed in organic agriculture. These are some small data, a couple of years of them, coming from cherries 2021, 2022. I should affirm that luckily we can compare the couple of years, because cherry trees in our region is a risky cultivation, because it's more the atmospheric change, climate change, that can affect the presence or absence of quality of the cherries, like this year. We lost the first ones for an heavy rainfall, happened not more than 15, 20 days ago. And 2021 and 2022, some of the data are comparing. But anyway, it's quite important to tell that the cherries that were treated with compost, vegetal one, ACV, plus compost tea, presented a higher sugar content than the one that were without any kind of treatments, or even the one treated with, let's say, normal fertilizer. As a general baseline, the untreated samples with any kind of addition were not so rich in sugar and not so generally inferior even as quality compared to the others.
To put things into perspective, here are the strengths, weaknesses, opportunities, and threats analysis that were conducted on the example previously presented.
A brief introduction to the technology. Why we develop this innovation, that is blow device? First of all, because it is necessary to extend the shelf life of fruits and vegetables in order to improve the presence on the market and to reduce the loss in all the value chain. The strategy that we can adopt to reduce the loss and to improve the shelf life are temperature and relative humidity management, the controlled atmosphere inside of the cold room, and modify atmosphere packaging. These are the normal strategy that we can use for food and for fruits and vegetables. But the problem is that for fresh fruits and vegetables, the controlled atmosphere packaging is very, very difficult. In general, we use low level of oxygen, we increase the carbon dioxide level, and we maintain a relative humidity very high inside of the package in order to reduce the respiration, to slow down the growing of the microorganism, and also to reduce the ripening process of the product. But for fruits and vegetables, it's quite complicated because the fruits and vegetables continues the metabolic activity also after harvesting, and so they consume oxygen and they produce CO2, they produce ethylene, they produce many of flavors that remain inside of the package if the package is completely sealed. And for this reason, we have an accumulation of CO2 and we have a reduction of oxygen that makes very complicated the shelf life of the product. And all of us, we have experience with fruits and vegetables, with fruits that are sealed. What's happening?
Yes. Go on, Giancarlo, go on, please.
Okay. The problem is if we have accumulation of CO2 and we have reduction of oxygen under the level, the minimal level required by the products decay. So it's very important to guarantee the exchange of the gas from inside to outside and from outside to inside in order to maintain the level of CO2 and the level of oxygen to close to the optimal level required for each type of product. For this reason, we develop this innovation. In a few seconds in this presentation, in this slide, you see what's happened during 1 day of storage. Blue device allow the exchange of the gas from inside to outside, and you see the package inflates, and then when the pressure inside of the cold store room increase, it deflates. And so during this process, it is possible to exchange the gas, so renovate the atmosphere inside of the package, so to let the entrance of oxygen, to let the CO2 go, the exit of CO2 from the package. This is a patent, a national and international patent, and it was recognized by the UE Commission in 2020 as a key technology. The most important and the reason why we receive the patent is because this device allows the bidirectional flux of the atmosphere. So we allow the entrance and the exit of the gas from the package without any contamination of the product that is inside. These are the results that we had in Oltre.bio during the test in Oltre.bio. We improved the storage of cherries from 10-12 days that are normally the shelf life for organic products without any kind of treatment and without any modified atmosphere packaging. We arrived to 62 days, and I can guarantee 50 days for the storage of cherries using modified atmosphere packaging with blow device. So with the possibility to exchange, to reduce the CO2 content inside of the package. For grape, the improvement of the shelf life is much more interesting from one side, because normally the table grape, organic table grape, so without sulfur dioxide treatment, is possible only for no more than 1 week. Second, because we have different results for different variety, but in any case we arrived to 30 days with superior seedless, but with 30 days without any decay, and we arrived to 45 days for Scarlotta seedless. But we test, of course, we tested this technology for many different type of products, and we have very interesting result, of course, different from the different type. For salads, we improved of 7 days the storage, but this means that for ready-to-eat salads, this means 7 days means that we increase the shelf life of about 100%. But the important experience that we made in the Oltre.bio experience was the change of the strategy that we applied for that we used for packaging the product, because the producer asked us to improve the dimension of the package in order to store the bulk product inside of the package for the first time, for the first period of storage, and then to pack the product in small packages. For this reason, we developed different applications. So we had the first application that was for small package, the second application that was for medium, was for grape, and this is for 7.5, 15 kilograms of grape, and the third type was for bulk, so 200, 300 kilograms of product in beans. This is the machine that we developed for the producer that tests with us the technology in his farm. This is the machine that seal the package, create the modified atmosphere, and make possible the storage in modified atmosphere during the first period of the storage. So it is, you can see, it is in bulk condition. The second machine, and this is the most important, it was applied in Romanazzi farm, and we installed in the, excuse me, I stopped for 1 second. You can see that the machine, this is a flow pack, is a horizontal machine. Horizontal is very old. We didn't change anything in this machine, but only we install the, it's like an add-in, it's like something that we install on the machine in order to avoid to reduce the efficiency of the machine and to change in terms of mechanics of this machine, to change the machine to avoid that the guarantee is not valid for the. And so we install the prototype that we developed during the Oltre.bio project. This machine apply and follow the packaging machine, the flow pack during the packaging operation. This is the reel that only changed the path. You can see that they are preparing the reel. I go faster. Okay, they prepare the reel, and then, excuse me, I go home. It's only to show you that, you see, and this is the application phase. You can see that the application happened during the movement of the reel, of the film, so we don't stop the production. So we don't affect, we don't change the production rate of the machine. In this way, it is possible to apply this technology without any change in the production protocol that the company has. We can follow the speed of the machine starting from 10 devices per minute to arrive to 60 devices per minute. So this is the packaging operation. The baskets are ready for the packaging. They enter inside of the machine, and then they are flow packed inside. Please note that the device is a yellow one, that is a medium respiration rate. Then it's very easy. This is the packet product. This is the packet product, and what is interesting from my point of view is that in this case we can change the breathable properties of the package only changing the device inside of the that we apply. So this is the blue one. It's only we can use the same machine. Everything is the same, but only we change the device inside of the applicator. So it is very interesting because in this case we can use different device for different product or for different package shape. The potential of this technology. The potential of this technology is very important because we have a lot of companies that pack product, a lot of companies that make product that has to wash and ready-to-eat products. The device at the present have no competitors on the market. Because it's the only one that makes possible the exchange, bidirectional exchange, and it is interesting because we can make this, we can build this device in many different plastics, also bioplastics, and we can use, we can apply with the same machine. So it has an important potential. The cost is 0.08 euro per package, range from 0.08 euro per package to 0.40 euro per package, depending from the package. At the present, I can say frankly that it seems too high for the product that is packed, normally packed. So we are trying to reduce the production cost in order to improve the interest of the producer to this technology. And this is top. If you have any question, I am very happy to answer.